So those are the basic operators. And in Python, we have, I wouldn't say advanced operators. I would just say there are more operators for more interesting operations. This is my favorite one, the modulus. I drastically underestimated the usefulness of modulus when I started programming. The modulus operator is symbolized by the percent sign. And what it gives us is the remainder that I have left when I divide this by this. So it does the division, but all it gives me is the remainder. Okay? It's a little confusing, and you're wondering, why would I use that? It is surprisingly useful in all kinds of programming situations. I guess that's sort of a given because it exists, and we know that this programming language was built on other programming languages. So at some point, somebody said, hey, you know what would be really useful is if we had a thing that could give us the remainder. And so but modulus exists in a lot of programming languages. So modulus is very useful. So 10 divided by 3, we know that 3 goes into 10 3 times. 3 times 3 is 9. So we have a remainder of 1. So the modulus of 10 and 3 is 1. The other thing that I think is kind of fun is called floor division. Now, really important thing to remember here. Pro tip, ready? When you do regular division of any two numbers, the result is always a float data type, even if it goes evenly. So if I divide 9 by 3, I get 3.0. Okay? Always, 100% of the time. Floor division is going to give me an int, even if that doesn't go in evenly. So floor division, 10 floor divided by 3 is going to give me 3. Now, it's not a precise division, but it is very useful in terms of when you want to get an approximate this divided by this, but you need to have an int as a result. There's a lot of times when you need to have an int as a result. Now, what I could do is I could do regular division and then just convert it to an int. It does the same thing. It basically, anything after the decimal, let's just get rid of it. This is as useful as this. And so the answer here, 10 floor divided by 3 would be what? 3, right? Always an int. So division is always going to give you a float. Floor division is always going to give you an int. Very useful because there are lots and lots of times when you have to take the result of something like this and plug it into another function. And that function might say, I'm only going to take an int here. So if it only takes an int, then you got to do floor division, even though it's less precise. The increment operator basically says, I'm going to take x, and whatever's in x, I'm going to add 3 to it. Now, if x doesn't happen to be a numerical type, like a float or an int, this is going to give me an error because I can't do math on a string. Can't do math on a Boolean. I can do math on a number, right? So if x started out as 3, what would it be if I used this on it? 6, right? Yeah, it's basically just taking whatever is in x and adding 3 to it. A slower way to do it is the self-assignment. So I could say x is equal to x plus 3, which means basically I'm going to take something out of x, I'm going to add 3 to it, and then I'm going to put it back in x. So there's no other variable here. X is just incremented by 3. Increment is very useful, as are its cousins, right? The increment version of minus, division, multiplication, exponents, and floor division. You will notice no modulus here. There is no modulus version of increment, and the reason for that is it wouldn't really make sense to increment something and only have it return the remainder each time. That would be a weird calculation. Too odd to be useful.